Lesson 3.5, Arithmetic Sequences as Linear Functions. So our objective is to be able to recognize arithmetic sequences and relate them to linear functions. In other words, we're going to take the sequences and be able to write equations so you can predict what terms would be farther down the sequence. So by definition, an arithmetic sequence is a set of numbers in which the difference in successive terms is constant. Okay, let me try to put that in more plain English, let's say. It is a set of numbers that goes in order by adding the same amount from one step to the next. Each number in the sequence is called a term. The common difference is the difference between successive terms. They talk about it as a difference. As you move forward, you say, what does it take to get from one term to the next? What do you add on? Okay? You see it as adding on, but honestly, they call it a common difference because if you took the second one minus the first, that's what the difference is. You subtract it. So it's what the difference is between the terms in a row. So if you looked at 3, 5, 7, 9, 11, that list, you add 2 to go from one step to the next. Okay, one step to the next. The common difference is positive 2. If you had to name the common difference, it's a positive 2. Whereas if it went 33, 29, 25, 21, ... to go from one step to the next, the common difference in this case is -4 because it's going downhill. So you say the common difference is -4. Okay, so let's look at what kinds of problems you might have with this. Example A, it says find the next 3 terms. Okay, so this sequence is -8, -11, -14, -17, ... What I want to do is I want to determine what the common difference would be. So from -8 to get to a -11, what would I have to do? Tora? Subtract 3. So from -11 to -14, what would I have to do? Megan? Subtract 3. And from -14 to -17, what would I have to do? Subtract 3. So really you need to check and make sure that's the same. I don't think they're going to throw any in that are different, but just double check that common difference is the same thing every time. So you have to find the next 3 terms. So you'd start with -17 minus 3. Well, that would put me at -20. So my first of my 3 terms is -20. Then I take -20 minus 3, and that would put me at -23. So my next term is -23. And I take my -23 and subtract 3 more. That would put me at -26. So my third term is -26. This would be my next 3 terms. If I had to name the common difference, you would say -3. If you had to name the common difference. All right, next, we are going to write an equation for the nth term. We're going to write an equation. So if those wouldn't have all the same common difference, if one would be different, then you would just say that it's not an arithmetic sequence and you couldn't do it. Not possible. Yes?
So the sequence is not going to be addition or subtraction? This one will be multiplying?
If it's multiplying, then that would be called a geometric sequence, and that's not in this today. Okay, so these are purely add or subtract the same amount. Okay, so the next part here is what really this is all about. Writing an equation for the nth term. So you might end up with this sequence, and they give you the first 3 or 4, and then they might say, what's the 50th term? Or what's the 25th term? And you know what? We're all perfectly capable of sitting there and adding or subtracting the same amount 50 times, but sometimes we don't have time for that. So writing this equation for any term based on the first few, that's really what we want to do here in algebra. So what you do for any term, a to the nth term, you first put in the first term, and then you take however many you want, minus 1, and add, or multiply times the common difference. Okay, so if they tell you they want the 10th term in the list, then you take 10 minus 1 and take 9 times that common difference, but you start at the first term. So we're going to take this and we're going to try it on this sequence. So 7, 13, 19, and 25. What you need to do is figure out the common difference. So from 7 to 13, what is it? Jared? 6. 13 to 19, 6. And 19 to 25, 6. So the common difference, I'm going to say D, is 6. So find the equation for the sequence. We're going to go A sub n. That means any term n. And I'm going to write the whole formula here so that we kind of get the hang of it. So you put A sub 1, the first term, plus n minus 1 times D. Now this one is not saying any specific term, so we're going to make it very general. A sub n, that means any term we want. What's the first term in the sequence? 7 goes in for 1. We're going to leave n minus 1 because they've not told us a specific one yet. And what's the common difference? 6. And then at this point, we're going to clean this up just a little bit. Do you see something we could do? Distributive property, sure. So 7 plus 6n minus 6. One more thing to kind of clean it up. Any term n would be 6n plus 1. I combined my like terms of 7 and negative 6. So this sequence is A sub n equals 6n plus 1. Now, if you look below there, I don't want to scroll up right now because I'll lose my equation. But if I look down right here, part C says find the 50th term in this sequence. So I don't have to start over. I'm going to use that equation we came up with. And I'm going to do this. A, and this is kind of strange. You see how it's got the little n down below it? That's called a subscript. I'm going to put a 50 down there. That means it's the 50th term. Equals 6 times 50 plus 1. You plug whatever term they want in place of n. So the 50th term is 6 times 50 plus 1, which is 300 plus 1, 301. So you're going to have to use the formula, the first term plus n minus 1 times the common difference. You're going to need to know the common difference, and you're going to need to know the first term, which you should be given that in the list. You make the equation for any generic term n. Then once they ask for the specific one, you plug that number in place of n and evaluate it. So 301 would be the 50th term in that sequence. Yes?
Don't we still have to do something for the A50 at the beginning?
No. You're just, that A sub 50 is saying the 50th term. Whatever little number you put down there, it's called a subscript, that's the term that you have. Okay, now let's look and see what else is down here. Okay, one more, good. It says, write the equation for the nth term. Find the 12th term, and then which term is 172. So this is good. This sequence, 1, 10, 19, 28. So you start off by saying from 1 to 10, what do you do? How much? Add 9. 10 to 19, add 9, and 19 to 28, add 9. So my generic or general equation, any term sub n, that means the nth term, is equal to, what's the first term? 1 plus n minus 1 times, what's the common difference? 9. We're still leaving it general, so a sub n. 1 plus, go ahead and do distributive property, 9n minus 9. Combine like terms. Here's my general equation. Any term, any nth term would be 9n minus 8. So that's the equation, 9n minus 8. First question is find the 12th term. So it wants the 12th term. So here's what we would do. You'd say a sub 12 because that indicates it's the 12th term. 9 times 12 minus 8. That means 108 minus 8. The 12th term is 100. Which term is 172? Well, that's a little different. I'm going to put 172 in for a sub n. And 9n minus 8, now just solve for n, that'll tell you which term it is. Add 8. And 180 equals 9n. Divide by 9. And n is the 20th term. Olivia.
Did you get 172 by adding 72 from the 100?
No, I got 172. That was part of the question.
Oh,
The question was write first, so this had 3 parts to it. Write the equation for the nth term. So they give you a sequence. So you use that general formula just to have it for the nth term. So this was my first answer right there. Then it says find the 12th term. So that's my second answer. And then it says which term is 172. So you work backwards basically, putting 172 in for the a sub n, and you find that it's the 20th term. Okay? So you could be asked to do any of those things, but it all starts with writing that equation.